Good day, students. Welcome to Step Up E-tutors Functions Part 2 Mathematics Online Tutorial. My name is Lerato and we will be looking at some past exam questions. And this tutorial will be based on the NSC Grade 12 test June 2022. We will be tackling question 6 and question 5. If you haven't subscribed, please be part of our wonderful family and remember to share and like. Okay, so we're going to start with question 5, which reads, given f x equals to log a base of x, p is a point on the graph of fx. The asymptote to the graph is y-axis. The graph intersects the x-axis at b. We are going to start with 5.1 by first writing down 5.1 y equals to log a base of x. Then we're going to indicate to our marker that we're substituting p, which is 625 for x and 4 for y. Once we substitute on y, we have y equals to 4 equals to log a base of 625. The next step is to write our answer in exponential form, which is base to the power of y equals to x. So base, this is the base, to the power of y, which is 4, equals to x, which is 625. Then you're going to type into your calculator equals to 625 shift fact. Then you're going to get that a to the power of 4 equals to 5 to the power of 4. That means once you have the same exponent, we are going to ignore the exponents and have a equals to 5. For 5.2, next, it reads, write down the coordinates of b. So b is the x-axis. It's on the x-axis, which is the x-intercept, which is y equals to 0. So we're going to take our 5.1, which is y equals to log, and then in place of a, we're going to write down 5 base of x. Then we're going to substitute our y equals to 0. So we will have 0 equals to log 5 base of x. Then we write down our answer in terms of exponential form, which is, if you remember clearly, base to the power of y equals to x. Therefore, we're going to have base as 5 to the power of y, which is 0, equals to x. 5 to the power of 0, or anything to the power of 0, equals to 1. Therefore, we have x is equals to 1. And then since we had already determined that y is equals to 0 according to the x-intercept rule, then we're going to have a coordinate of b, which is 1 to 0. Next, we're going to look at 5.3, which asks, determine the equation of f to the power of -1, the inverse of f in the form of y equals 2. Okay, so the original fx equation is fx equals to log 5 base of x. If we're finding the inverse, that means we are going to swap y with x and x with y. So where we originally had an x, we are going to write down y equals to log 5 base, and then we originally had an x, we are going to write down equals to y, right? Then we're going to write it in a form of exponential, in the exponential form, which is base to the power of y equals to x. So the base in this case is 5. The y now is no longer the normal y, but the y now is x equals to y, right? That means our equation of inverse is y equals to 5 over x. Next is 5.4, which reads, if the point P is reflected and about the line of y equals to x, write down the coordinates of the image point of P reflection. So the original P is P 625 and then 4. So if they're saying that y is equals to x, so that means y is equals to x, and then the opposite way as well, x is equals to y, so x is equals to y. Therefore we have our new reflected coordinate as x is equals to 4 and y is equals to 625. I hope that everything is clear and makes 100% sense. Next, we are going to move on to question 6. Okay, and it reads, the graph of gx equals to 3 open brackets x minus 2 close bracket squared minus 12 is sketched below. O and C are the x-intercepts of G, and B is the turning point of G. Px equals to mx plus q passes through O and D. M and Q is parallel to the y-axis, with N and Q on the graphs of P and G respectively. Okay, so we're going to look at 6.1, and it reads, write down the coordinates of B, the turning point of G. Okay, so I'm going to write down how it normally looks in terms of the standard form. So it's y equals to x minus p squared plus q. Okay, so if you have your equation written in this particular format, then your turning point is minus p q, right? So now that means, and this thing's not working, let's apply this particular principle to the normal equation in terms of the question that was asked. Okay, so that means B is minus P, so minus 2, and then the y coordinate is q, so it's the minus 12. Okay, that means we have b as positive 2, negative 12. 6.2 says find the value of t. So t is where okay, so t is the y coordinate of d. So what we can do is substitute d 3 to t into the gx, right? So we're going to say into gx. So we're going to have t in place of y equals to x. So apologies, so we need to substitute into the x because we have the x value. So it's 3 times 3 goes and replaces the x, minus 2 squared minus 12. Then we have 3 times 1 minus 12. That means t is minus 9. Okay, so 6.3 says write down the equation of the graph of p. Okay, so we have px equals to mx plus q. Okay, so what do we have on the graph? So at the moment, the only things that we have is the equation, is the coordinate of d, and also the origin. So O is 0 to 0 and D is 3, negative 9. Okay, so we can use these 2 points to find out what is the gradient of OD. So we're going to say minus 9 minus 0 divided by 3 minus 0. That means we have a gradient of minus 3. Okay, that means in terms of our original equation, we're going to now have px equals to minus 3x plus q. Then we will substitute one of the points on the graph. In this case, I'm going to choose to substitute in 3 minus 9. Okay, that means in place of px, we're going to have minus 9 equals to negative 3 times the 3 plus q. That means if you bring this minus 9 over the equal sign, you're going to have minus 9 plus 9, which means q is equals to 0. That means our px is negative 3x and there is no q. Next, we're going to start with question 6.4, which says determine the maximum length of NQ between O and D. Okay, so before we start with this particular question, I'd just like to explain a small principle. Okay, so let's say we have a graph here, so that's the quadratic, and okay, and then we say find the maximum or the minimum length between these 2 points. So let's say maybe let's give them coordinates. So this is A and it's 2 to 6, and then the other one, let's say it's B, which is 2 to 12, right? Okay, So the principle, if you want the length between A and B, so length of AB, you need to take the y value of B minus the y value of X. So the y value of B minus the y value of, not X, of A, right? That means it's going to be 12 minus 6, then you get 6, right? So this particular principle, I'd like you to remember it when we start looking at 6.4 individually. So it is important to notice that with this question of writing down the maximum or minimum length, we are using the principles or the rules of calculus. So as I stated, so when you're finding the maximum or minimum length of a particular distance, it is always important to use the first derivative. So optimization, I'll explain how we go about that. Okay, so let me just erase this bottom graph that I drew just for space. Okay, so in this case, so I stated that to be able to find the length, we need to say the y value of n in this particular case minus the y value of q, right? But now we don't have coordinates. What we have is the equations of the graph. So we need to use the equations of the graph, right? So we're going to say we're going to have 6.4 NQ equals to, so it's going to be y of n minus y of q, right? But in this case, we don't have coordinates. That means we are going to use the equations that are given to us. So we're going to say px minus gx. Then we have nq equals to minus 3x minus 3 times x minus 2 squared minus 12. Then we're going to have negative 3x minus 3 times, and then times this out. Then we're going to have x squared minus 4x plus 4 minus 12. Then we're going to have minus 3x minus, then we're going to times in the 3, right? So we're going to have 3x squared minus 12x plus 12 minus 12. So this is going to go away because it's equal to 0. That means we're going to have negative 3x. Then we're going to multiply in the negative, right? So it's going to be minus 3x squared plus 12x. And then I'm going to continue here at the top. Okay, so we're going to have NQ equals to negative 3x squared plus positive x. Then it's important to remember I said that when to find the maximum or minimum value, it is always the first derivative equals to 0. So it's the first derivative equals to 0. So we need to derive this, okay? So we're going to say 0 equals to, then the principle of deriving, you're going to say the base times the exponent. So it's going to be negative 3 times 2x. Then the exponent 2 minus 1, right? Then you do the same with the other one. So it's going to be the imaginary 1 times 9, and then x, then it's 1 minus 1 minus 1. Okay, I hope that's not very clear, but okay, let me just rewrite it so that we have a bit more space. Okay, so to be equals to 0, then it's negative 3 times 2x, 2 minus 1, plus 9 times 1x, 1 minus 1, right? Then we're going to have negative 6, and then 2 minus 1 is an imaginary one there, plus 9, and then x to the power of 1 minus 1, which is 0. That means x to the power of 0 is 1. So there's a times 1 here. Okay. That means we have negative 6x plus 9 equals to 0. Going to bring our variables to one side. So it's going to be positive 6 equals to 9. Then we divide both sides by 6, right? That means we're going to have x equals to 3 over 2. Remember they said determine the maximum length between NQ. That means that they want the value, right? So NQ, the original NQ is negative 3x squared plus 9x, right? Which we find here. Then we're going to substitute x equals to 3 over 2. That means we are going to have negative 3 times 3 over 2 squared plus 9 times 3 over 2. Okay, so when you multiply everything out, you're going to have negative 27 over 4 plus 27 over 2. That means NQ is equals to 27 over 4 units. So remember they asked for the length, meaning that you need to leave your answer in terms of units. I hope everything was clear. Thank you very much for taking part in our lesson today. We would really appreciate if you would like and comment below if you have any other questions that you'd like us to answer. And if you'd like private tutoring lessons from myself, please email stepupetutors@gmail.com or WhatsApp the number 083 343 8245. Thank you. Bye.